So now we finally get to the idea of a derivative. So here's a definition of a derivative. The derivative of f, some function f, is given by the limit as h goes to 0 of f of x plus h minus f of x over h. Now, notice this will be a function of x. And now also notice there's more than one way to give this definition. We can also write this as the limit as delta x goes to 0 of f of x plus delta x minus f of x over delta x. These two are saying the exact same thing. It's really just a matter of which textbook you're using. I grew up on this. This is what I learned on. This is also another very common way to say the exact same thing. Now, there are other notations. Well, actually, let's talk about the notations because this is the limit process. But how do we denote the derivative? I don't want to write all of this every time I want a derivative. So, one of the notations is the most common probably is f prime of x. This prime says you have a derivative. F prime of x equals the limit as delta x goes to 0. F of x, f of x plus delta x minus f of x over delta x. So f prime is very, very common notation to denote the derivative. The derivative is this process. There are also other notations. ddx of f of x. This is saying I'm taking the derivative of f, and this dx in the bottom is saying I'm taking it with respect to x. So x is my variable. Now, that may seem kind of obvious because all of our functions are functions of x. Well, not really. If I had f of t equals t squared plus 3t minus 1 and needed the derivative, this would be d dt of f of t. Another very common notation, because very often we equate the idea that f of x is equal to y. We think of the vertical axis. So another very common notation is simply y prime. So the three major notations, let me clean it up a little bit here. The three major notations that you'll see is f prime, or f prime of x, y prime, or ddx of f of x. Actually, I should say four notations because it's very common to also say d dx of y, which is really more often written as dy dx. Okay, 1, 2, 3, 4. I lied. There's actually 5 very, very common notations that you will see quite often. And they all say exactly the same thing. Now, if I found the derivative and I wanted to evaluate it at x equals a, well, obviously, if this is the derivative of f prime, then f prime of a means once I found it, x is now a, go ahead and evaluate it at a. Another common, very, very common notation is obviously y prime of a. Although, you know, this is actually not that common. This is more common. But also, if I take d dx of f of x and then add to it notation, this vertical bar, which you typically read as evaluated at x equals a. This is saying make x a, which is the same thing as this. So these guys are really probably the most common notations to say, hey, I'm going to evaluate this derivative function at a specific value a. So if I wanted it at 2, I would say, well, what's f prime of 2? And saying f prime is proper terminology. When you say f prime of 2, I know you're talking about the derivative. Or ddx of f of x at x equals 2. Now, just a little bit more terminology here. The process of finding a derivative, the actual process of finding a derivative is called differentiation. D-I-F-F. Differentiation. Now, a function is said to be differentiable if, or at x, if the derivative exists at x. So if I take the derivative at a specific value of x, if it actually exists there, then I say this function is in fact differentiable at x. Now, a function is said to be differentiable on an open interval a, b if it is a differentiable at each point in the interval. Now, we would not obviously check every point. That's impossible because I don't care what a and b are. If it's an open interval, there's an infinite number of values between it. So really, to determine if a function is differentiable on an open interval, we're not going to find the points where it is differentiable. We take the opposite approach. We look to see if it's non-differentiable, if the derivative does not exist anywhere from a to b. If there's no place in here that it does not exist, then we come back and say, well, then it's differentiable on the open interval. Because clearly you can't check an infinite number of possibilities.